Hello and welcome back to this series on BookNLP in Python. If you remember from the last video, we looked at how to go into our output files and to actually do some character analysis. We really relied a lot on the .book file, which contained a lot of our character information. In this video, we're going to be covering event analysis. Now, event analysis is a little bit different because our event data is stored not in a separate .events file, rather in a .token file, which I covered in the earlier chapters of this textbook, specifically Chapter 3, Video 3, the output files. Now, what we're going to be doing in this video is kind of working through Chapter 5, which is live. As of now, this recording, which is early April 2022, we do not, in BookNLP, have a .events file or an easy way to go in and perform some kind of event analysis. What we're going to cover in Chapter 5 and this video right now are some of the steps that we can do to explore that .token file in a bit more depth, kind of get the data that we need and reconstruct it so that we can create a function that will generate for us at the output of BookNLP a new custom .events file that we can then use for some event analysis that we have in some future project. So that's what we're going to be working on in this video. At the end of the video and at the end of the textbook, you will have a special function that you can just copy and paste and use in your own code. However you see fit, you can add to it, you can take from it, you can change some of the variables if you want to. The choice is really up to you, but I encourage you to watch this video in its entirety, as I will be going through the different steps that are available in this function and how to kind of explain why they're there, and so that you can have a better sense of what the function will do and how to actually use it in your own project. So let's go ahead and just jump into a brand new Jupyter notebook, and we're going to kind of go through and go into that .token file and start analyzing it. So the first thing that we really need to do is let's go ahead and import pandas as PD, and I'm going to minimize this on the left and zoom in just a little bit so we can make this a bit more legible. There we go. We're going to import pandas as PD. So what this is going to do for us, it's going to allow us to load up a pandas data frame from the .csv file, which is essentially what the .token file is. So we're going to say df data frame is equal to pd.read csv. Even though this is a TSV or tab separated value, we're going to be loading it up as a read CSV. We're going to say data \Harry Potter. This is the directory in which our file lies. And then we're going to say Harry underscore Potter dot, I believe it's dot tokens. And then we need to pass in a special delimiter. Now, you'll see this in the actual textbook. All a delimiter is it tells you how to read and parse the CSV file. So we're going to say delimiter, I can never spell this correctly, I think that's right, /t, because what we have here is a TSV file. And if we load up df, we'll notice real quickly that we have a very large data frame that we saw in Chapter 3. It's got 13 columns that'll include a whole bunch of different data. Now, this is kind of difficult to parse if you're working within a Jupyter notebook, and so what I like to usually do is to kind of eliminate some of the unnecessary rows that we actually have here, so we can kind of parse it a bit more easily. And we can do this a couple different ways, but really what I'm going to focus on right now is just the simplest way that we can do this in pandas. So what we can do is we can make a new data frame by saying df is equal to df, so the original data frame. And what we're going to do is we're just going to grab the columns that we're interested in. So in my case, I'm interested in sentence ID. We'll see why in just a second. These are the important ones. Word, which is going to be the actual word itself. That is the token. The lemma, so the lemma of that token. And event. And this will make it a little easier for us right now to kind of parse out what's happening here on this smaller zoomed in screen. Let's go ahead and zoom down. And now we're able to see that we've got sentence ID, word, lemma, and event. Now, if we look over here, we can very easily kind of make out what each of these are. I'll go back and just real quickly explain them. Sentence ID is the unique sentence integer that refers to the sentence that the event is found in. The event is triggered by a specific word. There are, as we're going to see, a couple different things that can be in the event column. Mr., in this case, the word column refers to the word itself, the token. The lemma is the lemmatized form or the root form of that token. Now, real quickly, you can tell that we've got a couple problems with our event category. Whenever you see things like /t, you're going to get this NAN. It's not going to be any of the actual standard things for events. So let's go ahead and again limit our data frame to just things that don't include NAN so we can kind of take a look at our data and get a better sense of what it is. So we're going to create a new data frame called events, and this is going to be equal to our previous data frame so long as the event column does not contain is null. So it doesn't contain the is null or the NAN. And if we print that off, we'll notice that this NAN at the end, and there's a lot of them, goes away. In fact, there's about 6,000 NANs, and we got rid of all of them. So once we have that down, let's try to get a better sense of what might lie in the events column here. So let's go ahead and say event options. This is going to be the types of things that actually exist in our events column. We can say set, which is going to create a unique list of only one item representation in the list. We're going to say events.event, so grab that event column to list, and then we can print off event options. And this will tell us how many different things exist in that event column. As you can see, we've got two. We've got this O and we got this event. Essentially, event means that the token that we're looking at is a trigger word or an event triggering token within that sentence, which means that it functions as an event identifier. So what we need to do to understand and really kind of get a list of events is that we need to go through and again create a new data frame that eliminates or grabs only the actual tokens that deal with events. So let's go ahead and do that. We'll create a new data frame. Let's just call this real events. And all of this is to demonstrate what's happening here in the function, as we're going to see at the end of the video. So we're going to grab all the events data frame when the actual column of event is equal to event. And if you don't understand what's happening here in the pandas data frame, spend some time and watch my video series on pandas on this channel, and this will make a lot more sense. Essentially what we're able to do here is we're able to filter out all of the rows that do not contain the word event. So if it has the word event, it's going to retain in this new data frame. And as we can see, we've got 6,029 rows, which means we have 6,029 different events in the first book of Harry Potter as identified by BookNLP. So let's go ahead. We can kind of do some greater analysis on this, right? We can figure out what kind of unique words are actually used in this event as event triggers in Harry Potter. So let's go ahead and say event_words is equal to set real events.word. So we're going to grab that word column to list. And this will create for us a list of 1,501 words long. And this will be the event words that the first book of Harry Potter uses that are unique. Event words. Oh, I gotta make it into a list. Sorry, 1 second. Event words, and we can index the first 10 here. There we go. And we're able to see these are the first 10 event words. These aren't even the first ones used. They're just the first one in the list. They haven't been indexed or organized in any consistent fashion, but you can get a list of unique words that are actually used to find and identify words that are used throughout the book as triggering event words. So that's how you would do that. And you could do the same thing with lemmatization. This is covered in the textbook. But what I really want to get to is kind of the crux of this video. How do we take these event triggering words, go back into our data frame, and then find the sentence in which they belong and reconstruct that sentence? Well, we can do that a couple different ways. I'm going to walk through one way right here. So let's say we want to grab sentences. First, let's print off real events so we can kind of see what it all looks like again. This is our data frame that has 6,029 rows. So what I'll do is I'll go to a list of all the different sentences. So I'll say real events.sentenceid.toList. This gives me a list of all the different sentences and the sentence IDs, and we'll say the events is equal to real events.word.toList. I'm converting these into a list for this video and for the textbook because I think it's a little easier to follow along if you're not familiar with pandas, if we just kind of parse everything as an actual list. So what we can do then is we can go over the original data frame, print it off here so you can see it. We can go over the original data frame, and anytime we see a row that's got the unique sentence number from the sentences list here. Let's go ahead and print this off actually so you can see it. Anytime we see a sentence that contains, or a row that contains this token, or this number, the sentence ID, we're going to kind of grab all of the things in that sentence, and what we're going to do is try to reassemble that sentence using the join function in Python. So let's go ahead and try to do that right now. So I think the best way to do this is probably just to work with one sentence. So let's call this sentence 1 is equal to sentences 0. So we're going to be looking for any instance where the sentence ID 9 appears in our data frame. So what we can do is we can say result is equal to df, so the original data frame, df, when sentence ID is equal to, just make sure that it's represented as an integer, sentence. And when we print this off, we've got an error, sentence 1. There we go. And what we're able to then do is create this new kind of unique data frame of just the sentence ID 9 tokens, which means we have the whole sentence here as raw text without having to go into some kind of other file. So what can we do with this? Well, we can make a unique object here called words, which is equal to result.word.toList. And let's go ahead and print off words so you can kind of see what this looks like. We grab all of those words from that data frame. And then what we can do is we can re-sentence them. So we can kind of reconstruct the sentence. Now, there are going to be problems here with this approach. This is, again, just to kind of demonstrate what we can do with this data. But essentially, we can recreate that sentence using the join. Now, the one big problem that you're probably going to see with this is that in English, we typically do put our period right next to the letter that indicates the end of the sentence. We don't usually have a gap here, so you can clean this up a little bit by just doing some post-processing. But what you have here is essentially a reconstructed sentence. And so what we can do is we can kind of bring all of these steps together in one single function, and that's what's covered at the end of the textbook. So let's go ahead, or the end of the chapter in the textbook. So let's bring it together. So we're going to call this function grab event sentences, which is what I said in the textbook here, and it's going to take one variable here. It's going to be the file name that it needs to grab. And so what we're going to do is we're going to say df is equal to pd.readcsv, file delimiter is equal to /t. So essentially we're following a lot of the steps that we saw above. And what I'm going to do is I'm going to go ahead and pass in our file right now so we have all this ready to go. And so right now we have no error, so the function is working just fine. So what we need to do is we need to grab the real events, which is going to be equal to, in our case, df.lock. So we're going to grab any instance in that original data frame where the event category, the event column, is equal to events. We're just going to grab all those true events. And so what we need to do then is we need to grab the sentences. And that's going to be equal to real events.sentenceid.toList. And so what that's going to do, let me print this off so you can kind of see what's happening in real time. Sentences. This is just the step where we're grabbing those unique sentence IDs. And then what we're going to do is we're going to create a loop to reassemble all of the different sentences. If you notice, sometimes a sentence has multiple event triggering words. So we're going to have multiple indices in our output that are the exact same sentence, and that's what we want. We'll see why that's important in just a second. The next thing that we're going to do is having a set of event words, which is going to be equal to real events dot word.toList, and this is going to grab all those event words, and we want to keep those lemmas too because they're important for some kinds of NLP analysis. and we're going to grab that to lists. So we got everything stored as a set of lists, right? And now what we're going to do is we're going to create an object called final sentences, which is what we're going to append to, and this is going to be a list of dictionaries. We're going to create x is equal to 0 so we can iterate over the sentences and keep track of where we're at for sentence and sentences. So we're going to iterate over all these sentences, and we're going to say result is equal to df. And we're going to grab the instances where sentence ID is equal to our sentence. And so if this integer ID matches up with this case, we want to grab all of those words like we saw a second ago up above. And this is where we say words is equal to result dot word dot to list, and that's going to create a list of all of our words. And again, let's print this off so you can kind of see what's happening here in real time. I'm going to go ahead and just do this over the first 10. And what you're seeing is the output of all these different event triggering things and their sentences that correspond to them. So what we're going to do is create that resentence object again in this loop, which is where we just kind of simply naively join them all together. Again, there's better ways to do this, there's cleaner ways to do this, but I think this is the most legible. And then finally what we're going to do is we're going to append to that final sentence a dictionary. And this dictionary is going to consist of a few different things. The first thing is the event word, which is going to be our event word. Specifically event words at the index of x, which reminds me we need to say x is equal to x plus 1. And this allows us to essentially go over, and each time we're iterating over sentence, there are other ways to do this with enumerate, but this is the easiest way for newer users to kind of parse this. Each time we iterate over the sentences variable, what we're going to do is tick x up by 1 so we can grab event words at that index and event lemmas at that index. So let's go ahead and do that now. Event lemmas, and then finally what we're going to do is we're going to say the actual sentence. And this is going to be resentence. At the end of this function, we are going to return final sentences, which means I can do something like this. Data is equal to that. Ooh, and we have an error. What is the error? Final sentences dot append. Oh, it looks like I misspelled sentences here. There we are. And now, actually, let me do it this way. Data 10. What we have is an object returned that is our data. So why is this useful? Well, it means now I've got some event-centric data. For every single event, I have the event triggering word. It's a lemma, which means I can kind of go through and sort these all out however I need to based on word or lemma. I also have the sentence in which it actually appears. So I have a whole bunch of event-centric data. I can keep other things too. I could also keep the unique sentence ID if I wanted to. I could add that into the function. But what this means is that I can actually go ahead and make a new data frame with this data. So new df is equal to pd.dataframe, and I can just create it with data. And I've got this new CSV file that is event-centric, which means that now what I can do is I can say new df dot to CSV. I can say data Harry Potter dot events, and what I can do is I can say index is equal to false, and I can save this now as a new events file that can be accessed by pandas, by anything else. Now this does not have a delimiter as a tab, rather as a delimiter as a comma. So it's a CSV file. But I've got all this data now stored as a .events file. So I've essentially created a .events file for my own analysis with event-centric data. That's all we're really going to cover in this video. Hopefully you found it useful. Again, if there are parts of this that I kind of rushed over and you didn't understand, go to the textbook. I detail everything out there in text and I expand on things in a bit more detail. But hopefully you've got a way now to start exploring the event data outputted by BookNLP. If you get a lot out of this channel, please do consider supporting it via Patreon or by joining the YouTube memberships down below. I put everything out free for everyone, and that's how I want this channel to remain for all of time, and your support goes a long way in keeping that possible. Thank you.